We are studying some. We are studying state space model of electrical circuits, and in the last session, हमने दो state space we studied. We derived the state space model of two electrical circuits, and we'll be continuing with that. So let's take another example. So continuing, let's take this electrical circuit. So you have R1, you have C, you have L1, and you have R2, and V out is your output, Vi is your input voltage. So you have to find the state space model of this uh, particular circuit. So the question first is, how many state variables will this circuit be having? So we know the number of state variables now in any electrical circuit is decided by the number of energy storage elements. नंबर ऑफ एनर्जी स्टोरेज एलिमेंट्स. सो एनर्जी स्टोरेज एलिमेंट्स कौन कौन से हुए? एक तो इंडक्टर हुआ और दूसरा कैपेसिटर हुआ. सो यू हैव एन इंडक्टर हियर, you have one inductor and you have one capacitor. So that means the total number of energy storage elements are 2. So number of state variables for this particular electrical circuit will be 2. Inductor basically causes the current to differentially vary through it, whereas the capacitor will cause the voltage across it to vary differentially. And let these variables be x1 and x2. Now we know that one state variable is actually the current flowing through the inductor x1, and another state variable is voltage across the capacitor x2. Okay? You can take x1 as the voltage across the capacitor, you can take x2 as the current through the inductor. एक ही बात है, इसमें कोई डिफरेंस नहीं है. So you have x1 as the current flowing through the inductor and x2 as the voltage across the capacitor. x1 is IL and x2 is VC, that's the voltage across the capacitor. And our input is nothing but U. Vi is your input voltage, that means it is U. Now applying KVL, if this is loop 1 and this is loop 2, once you apply KVL in loop 1, you will get Vi, or you can say U is equal to current flowing through here, that be I, capital I into R1 plus L dx1 by dt. तो ये आपकी ये KVL इक्वेशन हो गई. ऐसे KVL जब आप लूप 2 में लगाओगे, the voltage across the capacitor x2 plus voltage across the resistor, that will be some current flowing through this circuit. So that, let me say this is I1, let me say the current flowing through this resistor is I2 into R2 plus minus rather L dx1 by dt is equal to 0. Okay? So by applying KVL in loop 1, KVL in loop 1, Applying KVL in loop 1, you have input voltage ut is equal to current flowing through resistor 1 into R1, that's voltage across the resistor 1, plus L dx1 by dt. जो इंडक्टर के थ्रू करंट है डैट इज x1, हमने उसको नोटेशन x1 दी. सो बाय अप्लाइंग KVL इन लूप 1, इनपुट वोल्टेज Vi इज इक्वल टू वोल्टेज अक्रॉस दिस रेजिस्टर प्लस वोल्टेज अक्रॉस द इंडक्टर. Voltage across resistor is I1 R1 plus L dx1 by dt is the voltage across your inductor. So this means जैसे मैंने आपको कहा dx1 by dt, we will not be writing dx1 by dt, we will be writing x1 dot. So you need to get used to it now quickly. So x1 dot is equal to ut. So let this be equation 1. अभी हमें I1 पता नहीं है इस इक्वेशन में क्या है. ऐसे ही KVL in loop 2. By applying the KVL in loop 2, you have capacitor के across voltage, that's actually x2 plus voltage across the resistor R2, that's I2 R2 minus L1 x1 dx1 by dt, x1 dot is equal to 0. KVL in loop 2 means voltage across voltage across the capacitor plus voltage across this resistor plus voltage across this inductor is equal to 0. So you have to find out the voltage across these. So you will be getting this equation. So again, equation 1 में I1 is unknown, equation 2 में I2 is unknown. We have to actually find out what the values of I1 and I2 are. Now we know the current through a capacitor. हमारे सर्किट में कैपेसिटर है, डैट इज उसके थ्रू जो करंट जा रही है डैट इज I2. I2 किसके बराबर होगा? डैट विल बी इक्वल टू C dV by dt. That is V across the capacitor is actually the voltage across the capacitor. In this case, we have actually denoted that by x2. So I2 will be nothing but C dx2 by dt, or in other words, you can say Cx2 dot. तो I2 तो हमें मिल गया, it is Cx2 dot. We can actually use this, but we still need to find out I1. By KCL, you know that I1 will be equal to current x1 plus I2. I2 अभी हमने निकाला, that is Cx2 dot. That means you can be using this as equation 4th and substitute in equation number 1. So substituting equation number 4 in equation 1 first. Equation 1 is ut equal to I1 R1 plus L x1 dot. Ut is equal to I1 R1. I1 is now x1 plus Cx2 dot into R1 plus L x1 dot. So this is equation number 1. So ये अब आपका क्या आएगा? ut simply u is equal to x1 R1 plus Cx2 dot plus Lx1 dot. Let this be equation number 5. ऐसे ही substitute equation number 3 in equation number 2. Equation number 3 क्या है हमारी? Equation number 3 is I2 is Cx2 dot. Equation number 2 हमारी है x2 plus I2 R2 minus L1 x1 dot is equal to 0. So ये जो I2 है यहाँ पे substitute करेंगे. So we'll be getting x2 plus I2, that's cx2 dot into r2 plus minus L1 x1 dot is equal to 0. Minus L1 x1 dot is equal to 0. So this is equation number 6. अब इक्वेशन नंबर 5 में एंड इक्वेशन नंबर 6 में दोनों एक ही साइड पे x1 डॉट भी इसमें है, x2 डॉट भी इसमें है. x1 in equation number 6 again you have x1 dot as well as x2 dot here. So using these two equations we can solve for x1 dot and x2 dot. So from equation number 6 what we can directly write is c x2 dot x2 plus cx2 dot r2, sorry, x2 plus cx2 dot r2 minus l x1 dot is equal to 0. ये आपकी इक्वेशन नंबर 6 है. तो इसमें से हम x2 डॉट निकालेंगे. So what we'll be getting is x2 dot is equal to so यहाँ से हम x2 dot निकालेंगे. So we'll be getting x2 dot will be L x1 dot minus x2 divided by CR2. So we have got x2 dot. Now x2 dot can be substituted in equation number 5. Once we substitute this in equation number 5, u is equal to x1 r1 plus rcx2 dot. rcx2 dot की जगह पे आपका 1 मिनट, दिस इज r1 cx2 dot r1 cx2 dot x2 dot की जगह पे आपका l x1 dot minus x2 डिवाइड बाई CR2 आ गया. U is equal to x1 r1 plus r1 cx2 dot plus l x1 dot. L x1 dot. So solving this equation x1 r1 plus c और c cancel हो गया. You have r1 divided by r2 l x1 dot minus r1 divided by r2 x2 plus l x1 dot. तो यहाँ से हमें एक्चुअली x1 डॉट निकालना है. सो x1 डॉट कंबाइनिंग दीज टू टर्म्स, x1 डॉट अंदर आपका l r1 बाई r2 है प्लस l और बाकी सब कुछ लेफ्ट हैंड साइड पे ले जाएंगे, राइट हैंड साइड पे रादर u माइनस x1 r1 प्लस r1 बाई r2 x2 r1 बाई r2 टाइम्स x2. सो ये लेफ्ट हैंड साइड पे ले जाके x1 dot is equal to right hand side rather u minus x1 r1 plus r1 by r2 x12. You will be getting u minus x1 r1 plus r1 by r2 times x2 whole divided by L R1 by R2 plus L. L R1 by R2 plus L. So this is X1 dot. So we can try to simplify this. So this means X1 dot is equal to L, यहाँ से कॉमन निकाल के you can have U R2 minus X1 R1 R2 plus R1 X2 divided by L R1 plus L R2. Fine. Or you can put this as X1 dot is equal to minus X1 R1 R2 divided by L R1 plus R2 plus X2 R1 by L R1 plus R2 plus U R2 by L R1 plus R2. Fine. So you can actually do this. Simplifying this, you will be getting minus X1, इसका कोफिशिएंट R1 by R2 L R1 plus R2 है, plus X2 R1 by L R1 plus R2 plus U R2 divided by L R1 plus R2. So this is X1 dot. We have this equation. इसको हम equation number 7 लिख सकते हैं. Yes. So equation, substituting equation number 8 in equation number 7. Equation number 7 हमारी क्या है? X2 dot is equal to L X1 dot minus X2 by CR2. X2 dot is equal to L X1 dot L X1 dot minus X2 by CR2. And this is our equation number 8. We have to actually substitute this in instead of X1 dot. So we will be getting L X1 dot की जगह पे आपको ये सारा substitute करना है यहाँ पे. Minus X1 R1 by R2 minus X1 R1 R2 divided by L R1 plus R2 plus X2 R1 divided by L R1 plus R2. X2 is R1 by L R1 plus R2 is U R2 by L R1 plus R2 plus U R2 by L R1 plus R2. So this is instead of X1 dot फिर minus X2 divided by CR2 है, इसको minus X2 divided by CR2. Divided by CR2. So what we'll be getting here is now minus X1 L CR2 multiply करके R2 cancel. You'll be getting L R1 by C L R1 by L और L भी cancel out हो जाएगा actually. L by CR2 into R1 by R2 L R1 plus R2 L और L cancel R2 cancel R1 by C R1 plus R2 plus X2 R1 by CR2 R1 plus R2 L और L cancel plus U L और L cancel R2 cancels out 1 by C R1 plus R2 minus x2 by cr2 minus x2 1 by cr2. तो ये x2 और x2 कंबाइन करके यू विल बी गेटिंग माइनस x1 r1 by c r1 plus r2 plus x2 r1 by cr2 r1 plus r2 minus 1 by cr2. That's actually r1 by cr2 into r1 plus r2. That will come out to be minus r2 divided by cr2 divided by r1 plus r2. r2 भी cancel out हो जाएगा, so this will be only minus 1 by c r1 plus r2. So you can do the mathematics. Minus 1 by c r1 plus r2 plus u 1 by c r1 plus r2. So it's time consuming, but it's a simpler method as compared to. So you have equation number 8 x1 dot, you have equation number 9, this is actually x2 dot. So putting equation number 8 and equation number 9 in the state space model form, you will be getting x1 dot, x2 dot is equal to something times x1 x2 plus something times u. अब ये x1 का कोफिशिएंट क्या आएगा? Once you check the coefficients, you find out that this will be minus r1 by r2 l r1 plus r2 times x1 r1 by l r1 plus r2 plus r2 by l times r1 plus r2u. ऐसे ही x2 dot is r1 by c minus 1 by c minus r1 by c r1 plus r2 minus 1 by c r1 plus r2 and plus 1 by c times r1 plus r2. So this is your x dot equal to x plus bu. और आपका जो आउटपुट है that is वोल्टेज अक्रॉस द रजिस्टर जो हमने क्वेश्चन में पूछा था. डैट मीन्स एक्चुअली I2 इंटू R2. I2 इज CX2 डॉट इंटू R2. तो x2 डॉट यहाँ पे सब्स्टिट्यूट करके वो जो हमने यहाँ पे निकाला है मल्टीप्लाइड विद R2, y यू कैन से विल बी इक्वल टू x2 डॉट माइनस r1 बाई सी r1 प्लस r2 इंटू सी r2. सी और सी कैंसिल आउट हो जाएगा, तो डैट मीन्स यहाँ पे माइनस r1 r2 डिवाइडेड बाई r1 प्लस r2 आएगा. सी r2 टाइम्स माइनस 1 बाई सी r1 प्लस r2. सी और सी कैंसल्स आउट, दिस इज माइनस r2 डिवाइडेड बाई r1 प्लस r2 प्लस 1 बाई सी टाइम r1 प्लस r2 इंटू डैट मीन्स r2 डिवाइडेड बाई r1 प्लस r2. So the thing is, you have to identify the equations. Once you identify the equations, you have to obtain x1 dot and x2 dot. Fine. हर किसी सिस्टम में यही है कि आपको KVL KCL लगा के x1 डॉट और x2 डॉट निकालना है. अब जैसे मैंने कहा आपको, x1 कैन बी आइदर करंट थ्रू द इंडक्टर और यू कैन चूज x1 एज वोल्टेज अक्रॉस द कैपेसिटर. दैट डज नॉट मैटर. ऐसे ही x2 कैन बी आइदर द करंट थ्रू द इंडक्टर वाला वोल्टेज अक्रॉस द कैपेसिटर. इट्स योर चॉइस व्हाट यू वांट टू चूज. खाली जो मैट्रिक्स होगा फिर उसमें जो एलिमेंट्स होंगे वो इंटरचेंज करेंगे पोजीशंस. बट मैट्रिक्स का आपको पता है, इफ यू मैट्रिक्स में अगर हम रोज़ और कॉलम्स को रोज़ को इंटरचेंज करते हैं उससे मैट्रिक्स पे कोई असर नहीं पड़ता है. फिर अगर कॉलम्स को चेंज करेंगे सो दे स्टिल रिमेन द सेम मैट्रिक्स. We are studied in matrix algebra. In short, you have to identify the state variables, you have to apply the KVL and KCL, and you have to obtain x1 dot and x2 dot. That means you have to obtain actually di by dt, where I will be the current through the inductor, and you have to obtain dv by dt, where V is the voltage across the capacitor. अब इस सर्किट में कितने इंडक्टर्स होंगे, कितने कैपेसिटर्स होंगे, वो आपको निकालना है. उसके बाद ये सिंपल मैथमेटिक्स है. यू हैव टू फाइंड आउट डी आई बाई डी टी, दैट्स एक्स वन डॉट, एंड डी वी बाई डी टी, दैट्स एक्स टू डॉट. लेफ्ट हैंड साइड पे डॉट टर्म्स होनी चाहिए, राइट हैंड साइड पे कोई भी डॉट टर्म नहीं होनी चाहिए, एंड देयर शुड नॉट बी एनी unknown variable on the right hand side. So once you do that, once you get those equations, you can put them in the matrix form, and you will be obtaining these kinds of state space models. Let's do another example. Let this be a resistor of 1 ohm, this be an inductor of 1 Henry, this be an inductor of 1 Henry, this is a capacitor of 1 farads. There is a resistor here of 1 ohm. Fine. ये आपका input voltage हो गया, and your output is the voltage across this resistor. So you need to actually find out the state space model of this particular circuit. अब number of state variables कितने होंगे? सबसे पहले it will be equal to the number of energy storage elements. इसमें एक इंडक्टर है, दो इंडक्टर है और एक कैपेसिटर है. That means the number of state variables equal to number of energy storage elements will be equal to 3, and let those state variables be x1, x2 and x3, whereas while x1 is the current through inductor L1, x2 is current through inductor L2, and x3 is the voltage across capacitor. ठीक है, let this current be x1, this current be x2, and this voltage be x3. ठीक है, अगर voltage across capacitor x3 है, इसके थ्रू जो करंट होगी इट इज सी x3 डॉट. अब यहाँ पे c क्या है? डैट इज एक्चुअली 1. ये 1 x3 डॉट है, तो इसके अक्रॉस जो करंट होगी डैट इज x3 डॉट इन दिस पर्टिकुलर केस. एंड ऐसे वोल्टेज अक्रॉस दिस इंडक्टर, अगर इसके अक्रॉस थ्रू करंट x1 है, तो इसके अक्रॉस जो वोल्टेज होगी डैट विल बी L dx1 by dt, that's L x1 dot. L in this case is 1, so this that means voltage across this capacitor is x1 dot, voltage across this inductor is x2 dot. Now by simply applying KVLs, let this be loop 1, this be loop 2, and this be loop number 3. By KVL in loop 1, and VI is nothing but U. KVL in loop 1, what we'll be getting is VI, that's U, is equal to voltage across this inductor, जैसे मैंने आपको बताया, that will be L dx1 by dt. L यहाँ पे 1 है, तो that means it's x1 dot plus voltage across this capacitor, that is x3. Fine. तो यहाँ से आपको डायरेक्टली क्या मिल जाएगा? x1 डॉट इज इक्वल टू u माइनस x3. फाइन. तो ये आपकी इक्वेशन नंबर 1 हो गई। यहाँ से आपको x3 यू हैव एक्चुअली फाउंड आउट x1 डॉट। यहाँ पे लेफ्ट हैंड साइड पे डॉट टर्म्स है, राइट हैंड साइड पे कोई भी डॉट टर्म नहीं है, राइट हैंड साइड पे कोई भी ऐसा वेरिएबल नहीं है जो अननोन है। Fine. In a similar fashion, by applying KCL at this node, KCL at node A, x1 is equal to x2 plus x3 dot. That means x3 dot is equal to x1 माइनस x2। तो ये आपकी दूसरी इक्वेशन होगी। आपने x3 डॉट भी निकाला। वी आर ओनली लेफ्ट विद x2 डॉट एक्चुअली। नाउ फाइंड आउट x2 डॉट। अप्लाई KVL in loop 2। KVL in loop 2 KVL in loop 2 means x2 dot voltage across the inductor plus voltage across this resistor. That voltage is actually shown as V0. Let it be V0 for now. Minus voltage across the capacitor minus x3 is equal to 0. So ये तो आ गया हमारा। x2 डॉट हमें यहाँ से क्या आएगा? x2 डॉट इज x3 minus V0. Let this be equation number 3. x2 dot is x3 minus V0. Equation number 1, equation number 2. तो find x2 dot, but equation number 3. On the right hand side you have an unknown variable, that is V0. We cannot represent a state space model in terms of V0. So we need to find out this V0. तो V0 को निकालने के लिए we have by applying KCL at node B। ठीक है। KCL at node B means जो वहाँ से करंट आ रही है ऊपर से, let this current be high, that current is equal to current coming plus actually I plus x2 is equal to this be I1, this be I2. I1 plus x2 is equal to I2. I1 plus x2 is equal to I2. So I1 क्या है हमारा? I1 is this voltage minus this voltage. This voltage, let that be this voltage is actually nothing but V0, and this voltage is nothing but VI. I1 is V0 rather V I. V is input voltage, U minus V0 divided by the resistor यहाँ पे बंद है। I1 is the current. I1 current is this voltage is VI, that's nothing but U minus this voltage, that is V0। ये जो यहाँ पे voltage है इसके across, यहाँ पे voltage V0 है, divided by this resistor, that's equal to 1 plus x2 is equal to I2. I2 क्या है? In the similar fashion, I2 is nothing but this voltage divided by this resistor, V0 divided by 1, which means U plus minus V0 plus x2 is equal to V0, which means twice V0 is equal to U plus x2, V naught is equal to U plus X2 divided by 2. Substituting this in equation number 3, what we'll be getting? X2 dot is equal to X3 minus V naught. X3 minus V naught is U by 2 minus X2 by 2. तो ये हमारी इक्वेशन नंबर 4 हो गई. सो हमारी जो इक्वेशन नंबर 1, 2 and 4 है, that we can now put in state space model. X1 dot, X2 dot, X3 dot. We have now 3 state variables is equal to, so we'll be having the 3 cross 3 element, 3 cross 3 A matrix is equal to X1, X2, X3. So equation 1, 2 and 4, as I said, can be now put in the matrix form. Equation 1 is x1 dot is u minus x3. That's actually 0 times x1 plus 0 times x2 minus 1 times x3 plus 1 times u. So that means x1 dot is 0 x1, 0 x2, 1 times minus 1 times x3 and 1 times u. And x2 dot is 0 times x1 minus 1 by 2 times x2 plus 1 times x3 minus 1 by 2 times u. So that means this is 0 x1 minus 1 by 2 x2, 1 x3 and minus 1 by 2 times u. And x3 dot is similarly x1 minus x2, that is 1 minus 1 and 0, 1 minus 1 0 0. So ये तो ये हो गया. और y जो हमारा था, that was actually the voltage across the resistor. Voltage across resistor वो भी actually हमने निकाला हुआ है. This is y v naught u plus x2 by 2. That means 0 times x1, 1 by 2 times x2 plus 0 times x3 and 1 by 2 times u. So this is the state space model of this particular electrical circuit that we. ये हमारा circuit था. Instead of L, C and R, we actually had known values. So ये जो hand form है, that looks pretty simpler. Fine. This was much easier to solve as compared to the previous question, even though it was a 3 cross 3 matrix. So similarly, you have to find out to do more, and so this is your assignment before we move ahead. If you have any questions, you can ask. This is your assignment. You have to do this, and you will solve. You will submit this by tomorrow 6 p.m. लिंक शेयर करूँगा, वहाँ पे आपको अपलोड करना है। ठीक है।